Hello, hello, hello. Can you hear me? Hello.
Hello.
Yeah. You can hear me, right?
Yeah, I can hear you.
Okay. In the last class, we ended up with a couple of problems. We'll try those first. So
Yeah.
the first one was this question. The smallest three positive proper divisors of an integer n are smallest three positive proper divisors of n are d1, d2, d3. such that D1 plus D2 plus D3 is equal to 57.
Yeah.
Then they're saying find the sum of the possible values of D2. Find the sum of possible values of D2. Possible values of D2. Okay. So obviously, like smallest divisors of n, the smallest one will be what?
A one.
So D1 is guaranteed to be 1.
Yeah.
After that, you have D2 and D3. So you have 1 plus D2 plus D3 is 57. So
Right.
you have D2 plus D3 is 56.
Yeah.
Now, uh, we cannot have like numbers which are not prime if you want to make it the smallest ones, right?
Right.
For example, uh, if you take a number like 24 or something, uh, the smallest divisors have to be such that, so if you think of the divisors of n, you will get whatever small prime numbers are there, those will be divisors, right? Which are in the factorization of n, right?
Yeah.
But if n is divisible by a combination of like you can have divisors like 1 p q, it could be pq if possible, right?
Right.
Like if n is big enough, then pq might be a divisor,
Yeah.
right?
Yeah.
What I want is to make the divisors the smallest divisors possible. So
Right.
I would try to avoid situations like this because I would like p and q to be there. Those are be smaller than pq, any product of primes, right?
Right. Yeah.
So I want d2 and d3 to ideally be some p plus q.
Right.
Obviously, they will not be like a small prime number like 2 and 3 and so on. You have to add up to 56 somehow. But you can easily guess now the 19 and 37, for example, right?
Right.
Those are prime numbers. Similarly, this is one pair. Similarly, 3 and 53
Yeah.
and 47 and no, 43 and 13. So these are possible pairs of prime numbers which add up to this, right?
Yeah.
Uh, it could be that there is another case where you have 1 p square and p and p square are both dividing the n, right?
Yeah.
Right now we took the case where two different prime numbers were the smaller ones, right?
Yeah.
But we could also have a case where p and p square are dividing. So there is no other prime number here. There is no q, but there is p and p square. So you could try and see whether p plus p square is 56 is possible.
Right.
P square plus p minus 56 will have roots. You can say that 7, I think, will satisfy, obviously.
Yeah.
So 7 is a possible thing where 7 and 49 become the divisors.
Right.
Correct?
Yeah.
Um, so D2 basically, what are the possible values of D2? we have gotten the smallest possible divisors in this case were 3, 13, and 19, right?
Right.
And the smallest possible divisors in this case is 7, right?
Yeah.
See, apart from this, there is no other case because P plus PQ cannot be taken because P plus PQ will be bigger than P plus Q, right?
Right.
We took P plus Q case, right?
Yeah.
And we took P plus P square case, which is the other way in which we could have the small divisors.
Yes.
So the possible out answers here could be for D2 could be 3, 7, 13, and 19. And the sum of possible values is becoming 3 plus 7, 10 plus 13, 23 plus 19, 42.
Yeah.
That becomes your answer here.
Yeah.
Okay. The other question was
Yeah.
basically determine all positive integers A, all positive A such that A is less than 100 and A cube plus 23 is divisible by 24. A cube plus
Right.
23 is 0 mod 24.
Mm-hmm.
So have you done anything here?
Yeah. So what I did for that one, I just said that then a cubed is congruent to 1 mod 24.
Hmm.
So then a automatically is also 1 mod 24. So then you
A
can just say,
automatically is not 1 and 24 necessarily. You cannot say that for sure. If you check A mod 24, there are many possibilities other than one also. A can be 0 mod 24 or 1 mod 24 or 2 or 3 up to 23 mod 24. It's not guaranteed that if A cube is 1 mod 24, it is always 1 mod 24.
oh, right. Um,
That that's
so then you could say that like a cubed is equal to,
if you check this series of numbers, when you cube it, you will
uh-huh.
get this is one possibility, but there are several others.
Yeah.
If there is 2 mod 24, you're getting 8, 3. 3 cube is 27, so 3. 4 cube is 64. So mod 24, that is clearly not 1. 5 cube is 125, which is 5 mod 24. 6
Yeah.
cube is 216. 216, if you do mod 24, how much it is? 240, it is 0, I think. 0
Yeah.
mod 24. 7 cube is 343. 343 will become basically 240 and 103. So it is 7 mod 24. 8 cube, like you have to check all these possibilities. 8 into 8 into 8 is 512. 480 and then 20, 32. So it is again 8. So
Yeah. I got 25 as my first one. Like 1 and then 25 for A. And then 49, 73, and 97.
you are just
But it's
using 1
probably
mod
wrong.
24.
Yeah.
That is one case. How do you know all the other cases up to 23 are not work? You have to, unless you have checked all the cubes till 23, you cannot be sure.
Right.
So that is not a correct approach. You are from a higher power, you cannot conclude a lower power is something. From a cube is equal to 1 mod 24, we cannot conclude a is 1 mod 24.
Right.
From lower powers, you can go to higher powers,
Oh,
not the
see,
other way around.
yeah, I mistaken that. Okay, so
From here, we have to figure out something. You can try using Chinese remainder theorem and say that 24 can be split into 3
8
and
and
8.
yeah, and then do
So,
like a cubed
s-
is 1 mod 8, and
1
then 1
mod
mod.
3 and 1 mod 8.
Uh-huh. So then a cubed is 3k plus 1 or 8k plus 1.
From here, you can say that because there are so few possibilities, you can check 0, 1, 2 for A.
Yeah.
Mod 3, you can see 0 mod 0 or 1 or 2. And it is obvious that only one mod 3 will work for A cube to be
Right.
1 mod 3.
Yeah.
So from here, you can say A is 1 mod 3. And here also there are only 0 to 7 cases, and you can see when is A cube 1 mod 8, when A is what mod 8. So obviously one if A is 1 mod 8, A cube will be 1 mod 8.
Yeah.
You can also check the other cases from 0 to 7. And
Right.
from there it comes that A should also be 1 mod 8.
Yeah.
If you have the combination of these two, now we can say we'll do the direct calculation and say that A is congruent to 1 mod 8. So A is equal to 8k plus 1. And then this thing was also 1 mod 3.
Yeah.
So 8k is congruent to 0 mod 3. And you can keep adding 3 to it. You'll say 3, 6, 9, 12, 15, 18, 24. That is same as 24 mod 3, 8k. And basically, you're getting divide by 8k is 3 mod 3, right?
Right.
Basically, k is coming as 0 mod 3, right?
Yeah.
So if k is coming as 3 mod 3, you'll get 0 mod 3. K is equal to some 3j. So from here now you put that here, you get A is equal to 24j plus 1, right?
Yeah.
Because we knew that A was coming as both 1 mod 3 and 1 mod 8. We are solving these two congruences by the Chinese remainder theorem method, and we are getting this. And we are getting from
Right.
here that A is congruent to 1 mod 24.
Yeah.
And now you'll get the answers 125, 49, 97 or something.
Right.
These are the possible numbers which are smaller than 100, which are 1 mod 24.
Yeah.
But it comes after verifying that not like the direct one step you are doing. You have to check
Right.
and make sure by proof that A is 1 mod 24, not assuming it, obviously.
Yeah.
So then you will get four answers less than 100.
Hmm.
Next question is this one. A number M, a number M is randomly selected from the set 11, 13, 11, 13, 15, 17, 19, and a number n, and n is randomly selected from the set. The second set is 1999, 2000, 2001, and goes up to 2018. What is the probability? What's the probability that the units digit of m power n is 1? What is the probability that the units digit of m power n is 1?
Okay. I got 2/5.
How?
Um, so I just like took the numbers. So let's say we took 11, right? So for 11, all of them are going to have 1 as the unit digit. So that's the probability of choosing 11 is 1/5, and then the probability of choosing a number that'll end in 1 will be 1. So then that probability is 1/5. And then
Mm-hmm.
same thing for 13. If you choose 13, that's 1/5. And then if you choose you have to choose a number. So 13, it's going to be 13 to the power 1 ends with 3, 13 to the power 2 ends with 9, 7, and then 1. So it gets 1 every 4. So then you're going to have to take multiples of 4. So that's 2000, 2004, so on, so on. So there's 5 of those. So then that's 5 by 20, which is 1/4. So 1/5 times 1/4. So that's uh 1 by 20. So then you have that. And then for 15, it's nothing's going to make it end with 1. So that's nothing. For 17, it's the same as 13, 1 by 20. And then for 19, it's 1 by 10 or 2 by 20. Yeah. And then you add them all up to get 8 by 20 or 2/5.
When we are doing units digit of anything, you can think of it as a problem where you have to calculate mod 10 value, right?
Oh, right. Yeah.
If you have 11, 13, 15, 17, 19, then that m itself can be written as 1, 3, 5, 7, 9, mod 10.
Yeah. Right.
So all the numbers for 1 will be fine because 1 power anything will be a 1 only, mod 10.
Yeah.
For 3, we know that the powers go in pairs of 4,
Yeah.
like you have found out, right?
Yeah.
3 power 1 is 3, then 3 power 2 is 9, then 3 power 3 is coming 27, and last one, 3 power 4 is coming with 1. So it goes in cycles like that. So 1 out of 4 will come, right? For
Right.
5, the powers will be always 5 or 0, right?
Yeah.
5 square will be 25, 5 cube 120. It is always ending with 5. So that will never work. For 7, again, you will do the same thing what you have done. But remember that you can simplify it instead of writing powers of 19 and all. You can do powers of 7 and 9, right?
Right.
Notice for 9, you are getting either you are getting 9 power 1, 9, 9 power 2, 81, either 1 or 9. So half the numbers.
Yeah.
That is why the probability here is double of this and this, right?
Mm-hmm.
Okay, so that is correct. Next one is basically what is the sum of all positive integers, n such that LCM of 2n comma n square is equal to 14n minus 24, I think. 14n minus 24. Sum of all the positive integers n which satisfy this condition.
Okay.
You have to figure out a way to get at this LCM nicely, right?
So if n was even, it would be n squared because that's the smallest multiple you're gonna get.
If n is even, you are getting 2k, n is 2k. So you're getting 2n is 4k, and this is 4k square.
Yeah,
So the LCM of these two is
is
simply
4k.
4k square.
Yeah. So you would write n squared is equal to 14n minus 24.
You're
And then
getting
solve
n
that.
square is equal to 14n minus 24, yeah. So
And then just solve that quadratic.
you're getting 12 and 2,
Uh,
right?
yeah. Yeah.
And if n is odd, you have to figure out the LCM of this. N is odd,
So 2k plus 1.
or
So,
you can just take n common here, and it is the LCM of 2 and n.
oh yeah, so it'll just be 2n then.
Because n is odd, there's no common factor, so it's just 2n. So it is n into 2n.
Yeah, so 2n squared.
So 2n square is equal to 14n minus 24. So 2n
Yeah,
square or n square minus 7n plus 12.
right.
So n is 4 and 3, but n was supposed to be odd. So we'll reject the case 4.
Oh yeah, right.
So n is equal to 3 is coming as the case from here. And these are your
Yes.
total possible answers. You will say 12 plus 2 plus 3 is 17 is your answer,
Okay. Yeah.
right?
Yeah.
Because we have done even odd, we have already counted all possible cases. There's nothing left now.
Yeah.
Okay. Next one is how many integers x, how many integers x are there such that x square minus 6 over x minus 6 is a positive integer. This has to be a positive integer. You have to find all possible values of x.
Okay.
Are you getting anything?
Um, I've gotten like 1, 2, 7, 8, 9, but that's just through trial and error. I'm thinking of how to do it like systematically. I guess you could say that like x squared minus 6 is kind of like, or like x squared minus 6 by x minus 6 is, I'm thinking of how to rewrite that into like something.
You should divide it and see. You
Yeah,
can
but then,
write it as x squared minus 36 plus 30, right? Correct?
right, yeah.
If you divide this first part, you'll get x plus 6 plus 30 by x minus 6, right?
Oh, right, right, right.
So this part is anyway going to be an integer if x is an integer.
Yeah, so then
You
that
just have
part,
to figure out this part has to be an integer. So
right,
basically x minus 6 is a divisor of 30, right?
yeah,
So if you list down the possible divisors, by the way, it could be negative divisor also. So we will be careful. We'll say 1, 2, 3, 5, 6, 7, 8, 9, 10, then 15, and then 30, right?
yeah,
And
right,
then we'll put all the negative signs in each of them.
right,
These are the possible divisors of 30, right?
yes,
So x will become automatically, you add 6 to each one. So you will get different values of x, right?
right,
But in all those cases, we should have to calculate whether this whole thing has to be a positive integer, right?
right,
So
yeah,
30 divided by x minus 6 in these cases is becoming 30, 15. It's the reverse order, right? 10 and 6 and 5 and 3 and 2 and 1 with
right,
negative signs here
yeah,
and so on, minus 1, right?
right,
And in each case, x values we already know are 7, 8, 9, 11, and so on. You keep adding 6 to all of them. So you can get x plus 6 value by adding 12 to all of them, right?
yeah,
You will get x plus 6 values in all the cases.
right,
And you're getting 30 by x minus 6 values are here, correct?
yeah,
So all the cases which give us positive answers, we'll accept the sum of these two have to be positive, correct?
yeah,
So
correct,
clearly the first 8 here will work, but when you try to do the negative ones, then there might be a problem. These will become too negative, correct?
correct,
So you have to exclude the possibilities where you are getting negative answer overall.
right,
But ultimately, it's an easy question only because you just list down the possible divisors of 30 and from there you figure out what is happening, which
yeah,
integers will work.
right,
You cannot do it random trial and error. You have to simplify this a little bit and then do something.
right,
Otherwise, you'll never get a hint that which numbers to check
yeah,
because there's nothing else here. The way to figure out whether it's an integer or not is first to divide it because this degree is 2, this degree is 1. Divide it and make it like this.
right,
Is it clear?
yes,
Okay, next one is this problem. There are positive integers x and y. Positive integers x and y satisfy the equations. The first equation is log base 10x plus 2 log base 10 GCD x comma y is equal to 60. And the second equation is log base 10y plus 2 log base 10 LCM x comma y is equal to 570.
Right.
And m is the number of prime factors in the factorization of x and n is the number of prime factors in the factorization of y, and you have to find out 3m plus 2n.
Yeah.
Basically, you have to find x and y. If you find x and y, then all of it can be answered. Remember, there is a simple rule that product of GCD and LCM is equal to product of the numbers, right?
Right.
Do you know that GCD and LCM of two numbers, if you multiply, you'll get the XY?
Yeah.
Right. So how can we use that fact here?
Um, you could say that the first equation can be written as 10 to the power 60 times x times GCD of xy squared, and the second equation
Like
can be
what?
written as
10 to the power 60. What is 10 to, how did you get 10 to the power 60 all of a sudden?
because you can add the two logs together, so then it becomes log 10 parentheses x times GCD of xy whole squared is equal to 60. So then you get
Okay.
10 to the power
But
60.
you don't need to do such things. If you can avoid writing large numbers like that, it will be better. You can simply add the two equations, right? What happens
Yeah,
if you add the two equations? You'll get this plus this, which will become log 10 xy, right?
yeah.
Plus, you can take 2 common and you have log 10 this plus this. That will become log 10 product of this and this, right?
So xy.
So that will become basically 630, right? You're
Right.
getting 3 log 10 xy
Yeah.
is equal to 630. And this becomes 210. And now you can say xy is 10 to the power 210.
Yeah.
So this we are getting. And okay, so what else can we get? Uh, The question has said they are positive integers x and y that satisfy this relation. Can we find basically x and y? That's the thing. So one way to get xy is 10 to the power 210 is if you assume that x is some 10 power a and y is some 10 power b, right?
Right.
Where a plus b is adding up to 210.
Yeah.
And you can assume that a is less than b without loss of generality. You're saying x is smaller,
Yeah.
right? And
Yeah.
then using this, we can put it back in the original equations, right?
Right.
Obviously, this is just one way. There are possibly other ways in which both are not powers of 10, right?
Right.
This is one case we are doing right now.
Yeah.
If we put it back in the original equation, you will get an equation which is simpler now because you will have a and stuff like that, right?
Yeah.
So let's see what is coming if we assume that. So a plus 2 log 10 and GCD of x and y. So a plus 2 log 10. Here the GCD, greatest common divisor, would be the smaller number, right?
Right.
GCD of x and y will be simply 10 power a now, right?
Yeah.
So this will give us 2a plus a is equal to 60. So you're getting 3a is 60, so a is 20.
Yeah.
And if a is 20, b is 190.
Right.
So you're getting x and y as 10 power 20 and 10 power 190.
Yeah. Okay.
That is
Yeah.
one case. However, like what about the other cases? That's the issue. There are possible ways in which it could not have been powers of 10. Right?
Right.
There are positive integers that satisfy. Okay, so basically you could have 10 power 210 is basically 2 power 210 and 5 power 210, right? So
Right.
x could be 2 power a, 5 power b, and y could be 2 power c and 5 power d,
Yeah.
where a plus c is 210 and b plus d is 210, right?
Yes.
And you basically now have four different variables, correct?
Yeah.
We will assume that we can't assume much now. Uh, but hmm, we have to check this also for possible solutions, right? Like there could be other solutions here. Here, this is a very simple assumption where we get one answer, but we don't know whether there are other answers, right?
Right.
Do you understand what I'm saying?
Yeah.
So now, if you do it, you will get log 10x. Okay, we'll have to make some simplifying assumptions like which power is smaller and which power is greater in order to calculate all this, right? So
Yeah.
we can say that earlier you were saying A and B were same. That's why you were saying 10 power A and all, right? Now A and B are unequal, right? Whichever one has
Right.
higher powers of 5 will have lesser powers of 2, right?
Yeah.
Do you understand what I'm saying?
Yes, I understand.
So let's assume that A is greater than C. That will imply that B is less than D. right?
Yeah.
So we are right now assuming these conditions, correct?
Correct.
The power of A is here higher than C, and but therefore B is smaller than D, right?
Yeah.
And we can also assume, we'll also have to assume whether A is bigger than B or not, right? So for
Right.
one case, we'll say A is greater than B for now. Because it could be that A is smaller than B. We are comparing now these and this, right?
Yes.
Do you understand what I'm saying?
Yeah.
An obvious equal case is A less than B. That's also possible.
Right.
Is it clear?
Yes.
So our assumptions are right now A greater than C, B less than D, and A greater than B.
Yes.
Now if you put it here, log 10x, so that will be log 10 2 power A 5 power B plus 2 log 10. Now GCD of these two, GCD always uses the lower powers, right?
Right.
So A is greater than C, so it will be 2 power C and 5 power B, right?
Yeah.
Is equal to 60. And then it will be log 10 y, and y is 2 power C, 5 power D, and 2 log 10. LCM will take the higher powers, right?
Right.
So 2 power A and B is less than D, so 5 power D, right?
Yeah.
Do you understand?
Yes, I understand.
Okay, so that will be equal to 570. And now we have to simplify. And remember, always A plus C and B plus D is always this 210 each, right? So
Yeah.
we'll simplify this because we are getting now log 10 combining everything, you'll get, or maybe we should just add it. We should just add it actually. So log 10, if you add it, you'll get 2 power A plus C, 5 power B plus D, right?
Yeah.
Oh no, but adding doesn't help. It will give me the same thing as before. Yeah, adding doesn't help. It will give me the same information that I had already earlier. So,
Right.
okay, so let's just see what comes from here. Just this equation, first equation. So you're getting log 10, 2 power A, 5 power B multiplied by 2 power 2C and 5 power 2B, right?
Yeah.
So 2 power A plus 2C, 5 power B plus 2B, which is 3B actually. So B plus 2B is 3B. And you're getting
Right.
log 10 of this is equal to 60, right?
Yeah.
So fine. And from the other side, you're getting C plus 2A and D plus 2D. So, okay, C plus 2A you're getting there. So I will just write the equations here. The other equation comes as log 10 2 power C plus 2A and 5 power 3D, right? Is equal to 570. Correct?
Yes.
Okay, so these two equations are there. And we know that C plus A is 210. So actually there is a log 10, 2 power 210 and 2 power A and 5 power 3D here. And here there is also a log 10 2 power 210 and 2 power C and 5 power 3B here. Correct?
Yeah.
Okay. Um, this is 570 and this is 60. Hmm. If I subtract these two, I'll be able to divide and I will get A minus C and 5 power 3D minus 3B. So I'll get log 10, 2 power A minus C and 5 power 3D minus 3B is equal to 510, right?
Yes.
But that still doesn't help. I mean, ultimately, we'll have to do some like remove the logs and try to guess the powers. Here also, we are getting something. We are getting 10 power 60 is equal to this stuff, right? So
Yeah.
we are getting, if you look at it, it is 10 power 60 is equal to 2 power 210, 2 power C, 5 power 3B. So 10 power 60 is already 2 power 60 and 2 power 5 power 60. So you are getting 2 power 60, 5 power 60 is equal to 2 power 210 plus C and 5 power 3B. So C is coming as minus 150, but that should not have happened. Minus 150 and B is coming as 20. But we wanted positive answers. Somewhere I made some mistake, I feel. Or maybe this doesn't have a solution for positives. A, B, C, D were supposed to be positive for us, right? Right?
Yeah.
That's how you are assigning the powers.
Yeah.
If from here, like if I have not made any careless mistake, from here I'm getting C is negative 150, right? But I cannot accept that answer. C is negative 150 and B is 20. Correct?
Yes.
I can't take that answer. I need positive answers. Maybe there is no other answer. It is possible. And the answer that we got earlier was the only thing.
Yeah.
But you have to check nevertheless. And the only way to check is to make reasonable assumptions and see the equations how they are with powers of 2 and 5, right?
Right.
Do you understand what I'm doing?
Yes.
We are getting these cases, and in this case, I tried to solve it, but right now it feels like it is coming, some weird things coming then. We are getting negative answers, right?
Right.
You can check it further and see if there is any other solution or not.
Yeah.
Uh, okay. Basically, we have done most of the types of questions that you will see in number theory. We will, once you come back, we will be doing different topics, maybe a little bit of algebra or counting. So,
Okay.
or we can also do geometry, but it depends on what your situation is.
Yeah.
Also, when is your school starting?
August should be like August 13th or 14th.
What are the courses you're taking? AP Physics 1, other than that?
AP Physics 1, AP World History, AP Seminar, AP Pre-Calculus, AP Government and Politics, AP Computer Science Advanced, and then Debate 2.
So these are the maths and physics stuff.
Yeah.
And right now you are in like which year of your high school?
Oh, I just finished ninth grade.
Okay, okay. So this is 1 year of high school is done, right?
Yeah.
So this is the algebra-based physics course, by the way. It doesn't involve
Yes.
calculus.
Yeah.
So you're planning to do calculus and all maybe next year or something like that, right?
Yeah, I'm taking calc next year. I mean, no, year after next year in 11th grade.
Okay.
Yeah.
But you can't take it earlier, or
Because
is it not allowed?
you have to take pre-calculus before calculus.
So pre-calculus you're doing this year, so next year you can do calculus then, right?
Yeah, next year, like because I'm doing pre-calculus in 10th grade.
Oh, right, right.
Yeah.
But you can't take two of them at the same time, no, right? You have to do this first and then only you can take calculus.
Yeah.
Okay, it's fine, no problems. But the problem is that in AP Physics 1, when you do, it will be like really like lame because you can't really do proper physics without calculus. Like it will be like half the stuff will be done and half of it will be left because you can't do calculus. So
Oh, okay.
the real physics will happen when you do AP Physics, the calculus version.
Yeah, AP Physics C, I think.
So that version you might be doing in 11th then, but uh,
Yeah.
so that is something that you have to prepare for properly. Like
Okay.
we will do calculus eventually sometime in the coming year, but I
Yes.
mean before you do calculus in school. So
Mm-hmm. Right.
this pre-calculus stuff, make sure that you do properly because it's basic
Okay.
only, but you need to know it properly for it to
Yes.
be useful in your exams.
Okay.
Okay, fine. We'll continue when you get back then.
Yes. All right. Thank you.
Bye.
Bye.